This lecture, like I let everyone know during the last one, I'm going to talk about Microsoft Office documents, which are the other common file format that people usually use to share around, business information, stuff like that. And so they're the other common carrier for a lot of malware when it's not delivered directly to you via a web page or a handful of other lesser carriers. So the official name for Microsoft's binary format used for Office, or I should say used within like the Office suite and a lot of other Microsoft programs, is called CFB, but some people refer to it as OLE or OLE2. But this is the one that's published on their website, so that's the name that I'm using right now. I think CDF is also another common one that I believe the file command actually uses. So I don't go into all those different names and what they mean. I'll just kind of stick with the CFB, and I'll actually have a definition of it because I can't remember off the top of my head what it means. This is kind of give a little bit of an overview here. In modern kind of office environments, it's really common to have to use a number of structured file formats to interchange work-related editable content. So this there's a distinction between this and the PDFs we looked at in the last class. In this spot, or I should say in this case, there's an interest in the parties that are interchanging these documents or these files being able to also edit the file that they receive and then send back an edited version. So they're kind of what I would say would be almost like draft formats or something like that. So where PDF ends up being a final presentation format, these tend to be in progress draft formats. And so that working use case is important when we kind of go later on to discuss the document structure, how it's organized, why it's organized the way it is, and then also why there's a number of tools to make working with the file format a lot easier. So as most of you are aware, this goes without saying, the most common suite is Microsoft Office. And again, like the suites that are common is typically providing these three functionalities: spreadsheets, slide presentations, and documents. So those three things seem to be the most common business cases. There are a number of others, and I list them here just kind of for your own knowledge. They're kind of worth at least knowing that they exist as you're working in Office environments. Though they may not be the most popular there, they will definitely be prevalent, and I've seen all of these employed in the Office environments that I've worked in since I got out of undergrad. So we're going to stick with focusing on Microsoft's suite of software and the formats that it uses. One thing I will point out is that every single one of these different Office packages do support the reading, so the interpretation and parsing of Microsoft's formats, as well as the ability to save their content in a Microsoft compatible format. Because of that, any of these might be kind of open, and a number of them I have seen, especially these here below, the Hancom, which is the Korean or Hangul word processor, plus all of its other subordinate applications, and the Ichitaro word processor. I've seen both of those because they're extremely prevalent in both Korea and Japan, be targeted when somebody's trying to send attacks to that particular, targets that are using that particular character set. One of the reasons why these are extremely popular overseas in those countries, and even at one point, I'm not sure if this is still the case, but at one point they were actually more common than Microsoft Office over there. And that probably is one of the reasons why I actually have seen these targeted specifically and not so much seeing the others targeted specifically, is that you're probably all aware Korean uses Hangul character set, and Japanese language usually uses a handful of different character sets. There's like a formal one, and then there's the kanji, and I think hanji is another one. So because they use all those different character schemes, and that also comes along with that is a certain layout, typically, top to bottom writing, stuff like that. Because of that, the traditional Microsoft Office just was never laid out for that originally, as it was originally targeted toward the U.S. and European markets. So because of that, they were popular as Microsoft Office, and even these others have started to adopt more flexibility in being able to lay out their content in that manner and allow you to author stuff in that way without it looking like a mess. I believe that they've started to make a lot of inroads in those markets because there is the added benefit of one-to-one interchangeability. But I point that out mainly because as you go and start working in different environments, it's important to actually do a survey of the tools that your users and your environment are actually using. So not to just kind of build kind of broad assumptions about, say, what operating system is being used, etc. Another example, and this was actually brought up at one of the Cincinnati B-Sides presentations not too long ago, that kind of defies a little bit of expectations, was this one presenter mentioned that at their particular company, the number of Windows workstations they had in their environment was 0. The number of Linux workstations they had in their environment was like 2 or 3. And this was a workforce of probably close to 1,000 or something like that. And then predominantly most people were using Mac OS X, which means that when they're going to defend their workspace and they're going to decide, say, what sort of mitigations they should have in place, their workspace wasn't really vulnerable to a lot of, say, Microsoft Windows attacks or even Microsoft Office attacks and things like that. It defied, I would say, the layout of their workspace and layout of their environment defied a lot of the prevailing metrics or prevailing ratios of workplace, say, OS and workplace software utilization, where traditionally Microsoft Office is the most dominant. That meant that if anyone wanted to target their workplace in particular, they would be able to learn, probably without too much difficulty, what was commonly used at their workplace, and then they'd be able to craft specialized attacks for that. If that person happened to be relying upon defensive systems that were supposed to be a lot more generalized, those defensive systems would probably be very ineffective in an attack targeting their business. So this is kind of one of the reasons I kind of talk through this, is it's important to recognize that you may see distinctions in your workplace and even in more general companies, for instance, that might surprise you, and it's important to kind of do usage surveys and stuff like that. But like I'm saying, it's important for all your knowledge to know that these exist, and that when this type of use case is trying to be solved, there are a lot of different ways to solve it. Although Microsoft Office still ends up being a dominant player, and so that's the most likely one you will encounter if you kind of roll the dice on where you're going to go after you graduate. So pivoting off that, we'll jump into Microsoft Office file formats. There's really two prevailing formats for Microsoft Office. The first one, which is the newer one, is actually called the Office Open XML File Format. That's actually got an international standard number associated with it down here. There's a lot of history to this, but I can't remember when the regulations went into effect, but at some point, a lot of the European Union countries wanted to basically put together regulation in their environment that said that if government information or official information was going to be interchanged in order to meet a lot of the transparency requirements or the sunlight requirements, that information exchange would have to occur using a file format that adhered to an open standard. So this is why Microsoft Office moved to this Office Open XML. So Microsoft actually was nudged in that direction by these regulations. And so there's actually a full, there's a catalog of about 4 different documents that explain how the Office Open XML, at least the standard layout for it's supposed to work. Later on, I'll give a kind of short little example to attempt to, to illustrate it. But, so I say that one is open standard. It's also a lot more straightforward. So it's a PKZIP file format, so you can use like any of the WinZip or any of those things, or even the built-in zip file capability within Windows to open, say, this one container that's your document, and then look at all the subcomponents that are embedded within it. So pretty much any Office document since like 2007 are usually distributed in this format, and the file extensions are these 4-letter file extensions that you see here. So if the document ends in file extension like that, chances are it adheres to this format. Prior to 2007, there was another one that was called, at one point was called OLE, and then later on went through a different set of revisions, and more recently, since I think 2015 or 2016, it's been given this name, and it's called Compound File Binary. What it is it's a binary file specification that's defined by Microsoft. They actually publish it themselves as an open standard, or I should say as an open specification. It's not an adopted standard by anybody, but it is an open specification to explain how the file format's laid out. And because of that, I'm able to use a lot of that information in today's presentation, and also a lot of people have been able to use it to build tools. This one is the original. This one's derived directly from the original Microsoft Word file format from long ago. It is designed to basically store arbitrary binary data within a single file. It's also commonly used as the general purpose binary format for a lot of other Microsoft programs as well. So you'll run into this file format, and you'll actually be able to use some of the tools that we'll be messing with today to analyze a lot of other Microsoft data files as well. So for instance, the installer files, the MSI, I think is what it's called. Those files also adhere to this format, and a number of other files that are used internally by various Microsoft applications. So knowing that, this approach, or I should say, this set of this knowledge set here ends up being broadly beneficial if you're doing, say, system forensics and things like that, because a lot of the binary files that Microsoft programs store, say, activity information and logging information, other stuff like that into, will also adhere to this format and are parsable by the tools or using the data structures we'll go through. So the latest CFB specification I linked here. So I'll make sure that both of these make it up on the website when I get all the lectures posted from this week and then and last week. So we'll start with the CFB file format because arguably it's the more common one that's targeted with Microsoft vulnerabilities. It's still used internally, so even though there's this open Office XML spec. There are a large number of features within Microsoft Word and Microsoft Excel and Microsoft PowerPoint that require binary data to be embedded in there, so a large binary container. And when that's the case, what you end up having is a data file that's based on this format is stored within that larger zip file. And then it's referenced by the document. And traditionally, that's a data file that is not part of the original international specification, so it wasn't required for the international standard requirements. And also typically embeds functionality or data that most non-Microsoft word processors, like the ones I listed up here, won't be able to interpret because they won't implement the functionality backing it. So it's a chunked data format. Basically what that means is the file's divided into sectors. So just like your hard drive is divided into sectors, these files are basically treated almost, you can think of them as little hard drives or little file systems. And they're divided into sectors. So every time they need more space in the file, what they do is they extend the file by one more sector and then magically have more free space that way. There exist file allocation tables that define an array of pointers to other locations that map blocks in the file to their ordering within a data stream. It's a mouthful. I do have a diagram later on that attempts to, actually you have two diagrams later on that attempt to explain that using more visual depictions. But if you remember when we were going through some of the C data structure and data model lectures, during that first one that we had, I was going through the different array layouts and everything like that. At one point we got to an example where the rows were allocated dynamically using new, and then they were freed with, or deallocated with the free keyword. And when we were analyzing that, we found out that I would allocate like an array of 12 bytes. I actually allocated 3 arrays of 12 bytes, so 3 rows, but they were not located contiguous to one another in memory. Also the other, benefit to that approach, that programming approach, is that if I don't fill up my table, my 3-row, 12-column table immediately, then I don't have to use up all the memory. So the same principle applies here, where they're trying to make a file format that allows you to dynamically allocate and dynamically arrange the file better, or I should say more flexibly to your needs. So in contrast to the data from a PDF file, this one creates a file structure where the data streams, such as images, documents, etc., are also not guaranteed to exist contiguous within the file, which means that if you remember in the PDF, you'd have a stream and then you'd have an end stream tag, and everything between those things was the entire image or child document or a JavaScript or whatever. In this case, the CFB file format actually supports a case where, or I should say supports the approach where your image data might actually be broken up in multiple places within the file, just like how your file system allocation works. And a lot of the design that went into this format is based upon a lot of the design that went into Microsoft's original file system, the one that they used with DOS and with Windows and everything like that. So they attempt to use the same approach and a lot of the same algorithms to allow you to organize data within an Office file. So I link a number of useful utilities and frameworks for dealing with this. So one of them is OLE tools, which is relatively new. It's a very featureful tool set, and I recommend you look at it. It's written in Python, and it's all open source. Another one that was written in Python is Office Parser. It's slightly older, but it attempts to do a lot of the similar things that the PDF parser did that we looked at on Tuesday. Finally, there's also this POI library from Apache that attempts to provide a Java API for building and also for loading in Office documents. So if you're wanting to use Java to do any of this work, there's an API providing some functionality for that as well. The examples that I'm going to go into are going to focus on this one, the Python code. But I have this here just so that anyone who wants to use like Java can has something to work with. So at its core, the CFB file looks like this. So as I said, it's divided into sectors. So this rectangle up here, and this is pulled out of that document that I showed you. So this right here represents the whole file. So this is the byte 0 within the file, and then this is the end of that file. So this would be the whole file. Within the file, it's literally broken up into a series of sectors like this. One of the sectors typically contains what they call a file allocation table structure, and that tells you which sectors within the which sectors within the file are allocated and then are used by various components, various streams. So first sector contains the header, so always contains the header at the beginning, and that's where all the information is defining top level file layout. So let me see. Yeah, here we go. So this right here is a document that actually goes through a lot of that stuff. And so this right here, I won't go through it completely. This is a list of the document header layout. So this is a data structure at the byte level. So all of these are the bytes that comprise the header. So from byte 0 to byte 31. So each one of these would be 32 bits wide, or 32 bytes wide. Sorry. Actually I think it's 32 bits wide, but anyway, yeah, and that ends up being the layout of the header. What this ends up doing is it tells what version of file format it's supposed to contain, so that, say, if an older version of Microsoft Office tries to open a newer file format, it can identify that it doesn't have the features necessary and warn the user that stuff may not be defined very well. Then what it ends up doing is it gives a list of the number of sectors that are assigned to different functions within the document. So some of the sectors are allocated to a directory or a tree. So if you remember on the PDF example we went through, that has a much simpler structure to it. But the way the document was arranged was you had a number of objects, and there was a parent object that was called your catalog. And that catalog was supposed to be the kind of root node of your document tree that linked to other things. This directory structure kind of provides the same type of functionality within the Microsoft Word document. It just happens to have a more kind of top-level structure to it. What this does is you can have multiple different sectors assigned to that particular piece of functionality. So maybe you need like 3 sectors worth of data in order to fully describe all of the contents of your file and the directory and layout of it. Then you have the number of fat sectors, which are sectors that describe the file allocation table. File allocation table is basically that list of pointers to where the data is located. So for instance, when we went through that example a week ago during the C data structures discussion, where we're doing the dynamic allocation using the new keyword or malloc, that ended up filling in basically an array of 3 pointers, filled in each one of those pointers with or I should say filled in each one of those locations with a brand new pointer that was pointing to where something lived in memory that we had allocated. The same is true here. Every time we need more space within the document, some entries in the file allocation table are modified so that they point to new sectors that are present within the file, and then they assign them roles, responsibility, that type of thing. So this one tells how many directory sectors, how many FAT sectors. This tells which one of the sectors in the file is the first sector for the directory structure, so that we can find that initial catalog. So just like in the PDF document, when we were going through it, if you remember on the trailer, there's actually a pointer to the catalog object. This one, this header has a top-level pointer to where the directory structure starts. There's also one more thing, and I'll get into this in a little bit, in a little bit more depth. But they added at some point a functionality called a mini file allocation table. And the difference between this one, the mini file allocation table, and the regular file allocation table is the file allocation table itself divides up the file into different sectors and then assigns them to different objects. The mini file allocation table actually will take smaller data within a sector. So any data that you need to store within the file that's smaller than one sector. And the default sector size is 512 bytes. So if you have like a couple of sentences that maybe amounts to 100 bytes total, maybe allocating an entire sector to that paragraph. And this isn't exactly how the document structure works, but just, hypothetically, if you wanted to organize things that way and write 5 paragraphs, that could take up 5 sectors if you were to store it that way. In order to solve that problem, they created a mini-FAT, which allows you to dedicate sectors to tiny data. And then they'll organize tiny data in a different manner than large data. So basically there's 2 types of things. They do work basically the same. The only real distinction between the two is that the allocation size for this is much bigger than it is for this. I think this one is always 512 bytes. And then the mini FAT is always I think like 64 bytes or something like that. So that would be almost an eighth of the size, I guess, or exactly an eighth of the size. So and then it goes and lists that here. So yeah, and so then we end up having this stuff listed here, and it goes into detail about all of these things. So I'll jump back to the slides now, and we'll run through the rest of these a little bit. So here, and I mentioned it right here, the sector size, so the actual sector size, the ones that the file allocation table is addressing, are always 512 bytes. And that's pretty consistent with most common operating system file systems as well. So most of the time, like on my Linux system and on your Windows systems and your Macs and everything, the file system breaks up the hard drive into 512 byte sectors. So, and the reason they're setting this up is because this is the goal right here, is to allow you to have multiple data streams within the file that you can work on independently. So if you think of, for instance, a Microsoft Word document that has images, has diagrams, it has your text, it may have video in there, all sorts of stuff like that. What they want you to be able to do is they want you to be able to edit each one of those components individually and not have to move around large sections of the file in memory, or I should say on disk. So a lot of the file on disk ends up staying the same, as the file is built out. So if you think of yourself as editing this one Office file over a long, say, 2 months or something like that gradually, you start adding information into these different spots within the file. Like you might edit this image that's held in stream 2, or you might edit this other document that's stored in stream 4, etc. What it's trying to allow you to do, and then you might have your main document in stream 1. What it's trying to allow you to do is that maybe I started out with very little content in the main document, and then I worked on these two things, stream 2 and stream 3. So when the document first started, there was almost nothing in stream 1, so it really only needed one sector to store that information. And then I started working on these two sub-items within it, which might be an image, or it might be a video, or it might be a table, or something like that. So I started working on both of these, and they ended up gradually needing to take up more space within the file. So it allocated more sectors as time went on, as I worked on it after a few days or whatever. And then after I had those things done, then I went back to editing the original file. And normally, in order to achieve, for instance, the outcome that the PDF file did, it would have had to move all this data down here constantly as I was working on my stream 1. And that's considered to be pretty inefficient as far as Microsoft Office is concerned. So they basically wanted to set it up so that the data on disk would move as little as possible after it was authored. So what they do is they say, okay, this one's growing, so I'm just going to allocate 3 more blocks for it as the user's editing it. But inside the file allocation table, and that's really what these arrows are representing. The arrows are representing the file allocation table mappings. And what they're doing is they're mapping sectors within the physical file on disk to logical sequences that build up the streams of data and other objects within the document. So basically, they end up providing an indirect table of references and pointers for all that stuff. So, and then finally, at the end of it, I might have added another couple sectors because I decided to add like maybe a header or something to the file. I don't know. But that's the logical layout that they're trying to achieve with this file format and the flexibility they're trying to achieve with it. And that's the reason why it is organized the way that it is. One of the key things to keep in mind about this means that if the attacker is trying to build an attack out of this stream, when I'm looking at the file on disk, I can't just write a signature looking for what that attack's going to look like in here. I would have to analyze each of these sectors individually, and the data might be organized out of order. So for instance, there's nothing that says that all of these sectors have to be sequential within that stream. The first sector in the stream could be this one, and then the second one could be this one, and then the third one could be this one, and the fourth one could be that one. So any permutation of sectors is totally acceptable as far as the Microsoft Office file format is concerned. Only in memory does the data itself, like the image or the macro or whatever, end up being consolidated and put in order. That's the representation that most of the attacks are going to live in, and that's the reason why we need to use a lot of tools to end up trying to reassemble this for ourselves. So another, and the same's true here, here, and here. So fun. So what they have, or I should say what this tool set, and so I put the link here again, what this OLE tools provides is a number of tools for working with it. I gave a list of some of the more common ones here. So OLE Browse, OLE dir. OLE Browse is nice, but very simple. It's a little GUI browser, allows you to navigate and view the individual streams of data and even extract them. The OLE dir allows you to list the directory of a document. So those directory sectors that I showed you earlier, it can analyze all those and display them to you. OLE map will do the same same type of analysis, but it'll do it on the file allocation table and also the mini-FAT, so it'll show you what the allocations are for the different sectors, kind of what their purposes are. OLE Meta gives metadata about the document, so every single Microsoft application has, for instance, the ability for you to set what language it was written in so that it'll be displayed properly, or who the author was, or what the official title is, or what the revision is, and all that stuff. Those are stored in metadata that this tool also has some capability to understand. And then finally, there's a functionality to dump macros, and we'll talk about those as well in a little bit. So I'm going to jump into, oh, not there, here. I'm going to jump into here. And what I actually made, I don't have it. Do I have? I don't think I have a application to read it on here, but I can read it on here. So, doc. So, I made this file, the test called test.doc, testdoc.doc, and it's basically some simple text and then an image, and the image ends up being a really big image. I think it's like, well, let's see, can I actually, yeah, look, I can do properties. Let's see if this works. Image. Yeah, I guess I can't see, but I can use like the macro language if I wanted. So this is kind of what I'm saying is like Office. So both like LibreOffice that I'm using right now, which is one of the ones I listed on slide 1, but also Microsoft Office allows you to like insert these macros. Like I could go and create a new macro in here, and I could actually have it occur, say when the mouse hovers over an object, or when an object's clicked, or when the mouse leaves the picture, like those types of things. So Microsoft Office has a much more featureful macro language that allows me to do stuff like that as well. But you know, a key thing here is there's an image that's not linked from somewhere external. This image is actually embedded and saved within that file format. And then there's this text here as well. And then all the font information and everything like this goes through and lists a set of acceptable fonts to render that text with. So that's what I have. So what I can do, is I can get the, let me see, I'm going to do this, background, black, foreground, white, there. Because that way this stuff will just show up a lot easier. It's almost unreadable if I have it on a white screen. This is what the directory looks like. So this is the stream and object structure for the file that I just created. So if you remember this diagram up here that I was showing you, stream 1, 2, 3, 4. What I'm displaying to you now is the directory, so it's after it has parsed all of this information and all of the arrows and everything you see here, it's listing out what these different streams are, what their sizes are, etc. So it's giving you the logical document structure, not the physical on-disk structure, but the logical structure that would be represented in memory. Also, what I should do, and I think I have it already, is you can also look at the this is the raw bytecode for the raw binary of the file on disk as well. So it might be easier if I do like this to show you So, but pretty much all of them, this actually shows this part easier too. All of the files that are of this format start with these 8 bytes. And basically this, a really easy way to remember this is almost like what you would call late speak for doc file, because that was the original file format, was Microsoft Word .doc. So they embedded that within it to kind of give a unique marker, a unique identifier to any file of that format. And then what you'll notice is that every 200 hex bytes, which is the that's 512 bytes just in hexadecimal encoding, is a new sector. So there's the beginning of a sector there, and then if I go down here to 400, here's another beginning of a sector right here, and you can see that the beginning of this sector ends up starting with like the word root entry. So if I remember correctly, you might be able to see that here. So you'll notice that there's a thing called root entry here. So that's the beginning of the document directory structure. So I can keep going down and I can see there's another sector here that contains some information. And then I can continue going down here, and then at 800, so we went from 0 to 200 to 400 to 600, and now we're at 800. I can see that there's another sector here that goes and describes some stuff. And this has some information in it, like Microsoft Word document, actually listed in document with a K, like almost like German or something. So one might be providing some information related to this stream right here. So that might be stream data about this. So if I keep going down, this has like, so this, all this data right here, you can see at 800. The next one that you're going to run into would be A00. So all this data here is part of this Microsoft Word document structure. I'm not going into the exact details of how this data structure is laid out, but you will notice that normal shows up here, which is one of the stylings, the style settings you're allowed to pick from Microsoft Word. Heading is listed right here. List is listed right here. Caption is listed right here. So there's all these pieces of information that are embedded within here. Here's the index. So all these features that exist in Microsoft Word are listed here. And then it ends like, yeah, like right here or something. So and then this ends up being the next one, I think, and that looks like it's probably a blob of compressed data or something. So yeah, and then here's another one. And so then there's this block, and this block contains some information that involves like font information and stuff like that. So perhaps that's where some of the, say, font info was stored. So, and then also you can have multiple, what's really common is that a stream actually is comprised of multiple sequential sectors, or say multiple sectors that exist anywhere within the file, which is why in one case, I don't know if you caught it up here, I'll jump back up here and show you. This one actually, so this word caption actually straddles a sector. That means that whatever this data was here, it was actually allocated to at least more than one sector. And so whether or not this and this occurs in adjacent sectors within the file is completely up to how that data happened to be organized efficiently within it. So there's no guarantee that in the raw file itself that this word caption is actually joined with the other half of itself. This half of it that I have selected and on down until you get to C00, that section of it could very easily have been allocated in a completely different sector, which meant that if you were trying to look in the raw file for the word caption, you would not be able to find it. You would only be able to find it if you were to reconstruct the stream structure out of the different sectors in, say, memory using a tool. So we'll look at the OLE browse tool now. This actually allows us to see these things here. So there's 8 objects total in here if you include the root entry. So 6 streams, and then one of them is a storage object of some sort. And it actually tells you where the first sector is for each one of these 2. So OLE browse, I'll open up the test doc right here. And you can see 1, 2, 3, 4, 5, 6. So 6 of these. So it's showing me just the streams that are in here. It's not including the word root entry, or this thing that's labeled as root entry here. It's also not including the object pool, both of which I believe are just artifacts of the underlying file format. And so they end up being, well, the root entry ends up being the root directory entry, so that's actually what I'm viewing right here. And then the object pool ends up being used for other like file-related actions. But I can go in here, for instance, and I can look at the Word document, and I can save this stream to a file if I want. So I can say stream, we'll call it 5 because that's the number over here. So now it's been saved to disk. And now I'll just cancel, I'll close, okay. I'll do that. Stream5.bin, and then it's all this. You might have remembered seeing this in the in one of the sectors in the file earlier on. We can actually look at this. So yeah, I can't remember how to do it. Yeah. But that's what I had thought too. I don't know. Yeah, I can't remember if there is a way to use Vim or not for it. I remember there was at one point, but I don't know what happened. So the stream 5 actually ends up being just almost exactly 140K. Whoops. So, but basically, you know, if I'm trying to look at an Office document, a tool like this allows me to walk through, and it has all the logic in there to walk through all those tables and pull out the streams individually so I can go and analyze them. So in this case, this one ends up being a stream representing the Word document. So in this specific case, it's the actual contents of the Word document. And so you can see, here's that paragraph I added into Microsoft Word. It's actually starting at this particular offset for some reason. I don't know enough of the internals of the Office format to explain why this is, but suffice to say it's got it right there. And then after that, you can actually see the JFIF, which is the JPEG, basically the magic number or the file identifier for the JPEG. So that JPEG image that I put in there as well, that had the cat inside of the paper towel roll, that's also embedded within this Office document like this. And I'm not going to go through all of it, but this is all compressed data that represents that image. So let's see, how far down should this go? I'll probably just do, if I do Shift G, it drops down to the bottom. And as you can see, that image is embedded within here. So I don't know all the specifics about it, but there is very likely some information in here that ends up referencing this data at this offset within the stream so that it knows where to find the JPEG data. And so somewhere up here in this encoding, that information exists. So I can't glean it off the top of my head right now. So then, the other thing that I will talk, and then I'll just, kind of one more thing that I wanted to show you is that I also saved the file. You can actually see the difference between these two file sizes right there. So this is me extracting the data from the container that only represents the Word document, and then this ends up being the Word document plus all of the other container information. So all the other CFB information. So this one ends up being me saving the file as the newer Microsoft Open XML format. And I'll just run this. And you can see that in this format, there's actually a large number of XML files. And then also these things that say .rels. And I can actually open this with a zip file reader. And it's got like content types. But the other thing that's neat is that in this case, it actually has a separate folder where it's storing all the media and everything that's used to build the document. So if I wanted to, let me see if this works here. Yeah, there we go. I can actually look through it. Whoops. So there's some XML stuff here that goes and explains a large number of document properties. So very similar to the basically telling the system what type of content that it contains, so that when something's opening up this zip file, it can determine maybe what other modules to load, that type of thing. I'll open this file up just to take a look at it. This one describes relationships. So what it's describing is our ID1 is this. So relationship that. So to this type, whatever that means. To be totally honest, I don't know what all these things mean, but what I can tell you is that they're using this to reference various files within this document. So they're describing some sort of relationship that these files have within the document, maybe some assigning them special functionality or something like that. Here's document.xml, which ends up being the thing that contains my paragraph. And then also contains a reference, I'll do this again, contains a reference to that image I created. And it says ID1. How I would try and find that would be, since I know it's in the media folder because I was looking around, I can probably just do JPEG around here. Or maybe not. Yep. It could also just be referencing it using this ID number. So if you saw ID equals 1 right here, oh, or no, here it is. It's probably just referencing it by name here, I think. Well, this is an entire container for the whole thing. So you're seeing this drawing, etc. So it describes the whole picture embedded there. But you know, kind of the goal is, or the thing that I'm showing you here, it's right here actually. It's this data here. So it's embedding using an XML markup language, one that's a lot more kind of familiar for you to try and be able to open and everything. So, or I should say be able to analyze with like a text processor or something like that. But all this data that you're seeing here that's represented in XML, that information is still embedded within the binary file as well. So Microsoft made basically an XML equivalent for all of that information like this when they came up with this new Open XML format. So the other functionality that's embedded within it as well. And so here's the Open XML layout, so that's the same document, just listed right here. The other thing that it supports is it supports executable scripts embedded within documents. So common language used for it is Visual Basic for applications. So most of the Office macros that you'll write, and I kind of gave a little peek into the user interface that's in LibreOffice to author those. Microsoft also has a similar feature. So a really good example would be, for instance, on if you have a slide deck for presentation or something like that, if you're presenting it with Office, you can embed macros so that it executes little pieces of code every time you advance to a new slide or something. For instance, if you want it to play a sound every time you advance a new slide or something like that, or if you want it to play a little animation or something. So those features are really nice, but as with anything, just like the JavaScript example I showed you from the PDFs last Tuesday, adding a kind of arbitrary and powerful programming language into it also opens up the door for that to be exploited by attackers who want to run arbitrary code on your systems. So I picked up a handful of examples that I found on the internet for using this feature. I also did grab I grabbed an example document that will take a little bit of time to go through as well. And I have it right here. So there's this Excel spreadsheet I found, and it's called payment.xls. So first, what I can do is look at it this way. And then as you can see, there's the doc file. So there's the file signature there. It's got the file allocation table laid out here. So these are all kind of pointers to what sectors are used and what they're used for within the document. And that's part of the reason why every single one of these sectors, or I should say every single one of these 32-bit pointers ends up being a constantly increasing value for the most part. So down here again, you have, let's see if we get down to, 200 ends up being that. Then at 400, you end up having root entry. And it talks about, there's also an entry that's referred to as a workbook and everything that's also part of that directory. So this is a directory right here, actually going all the way down here. So this is all one of the directory sectors, and it's describing something called a root entry, something called a workbook, something called VBA project cur or VBA project current, something just called VBA, and then a bunch of other information. So if I use this again, the OLE dir on it, it'll show me the data that I want to look at. One of the interesting things I would look at here is this particular stream. Because this has the word VBA project in it, might indicate to me possibly where the Visual Basic code lives. So what I might do is I might open this, payment.xls, and then extract this one. So that was stream number 7, right? So let's see what happens if I pull this out. stream 7.bin. And then also I can like hex view it in here, so I can actually preview it if I want to. So back to main menu. It also references this module, so I can go in here and look at this. I can't remember if this actually, or what, if anything, this has in it. Yeah, so this one actually has some code in it as well. So a lot of times what you'll end up having is the macro and then a module that contains information or contains data that the macro goes on to execute. So I might actually save this one as well. And kind of the way that I got here was when I was looking through this, and we'll go through the hex view. That's not super readable, but I will highlight what I saw was interesting. Was it actually references, for instance, some information on the file system of the machine that was used to build this, or I should say that would be used to run this. So for instance, it's got a reference to SQL and program files, Microsoft Office, Office 1.4, Excel.exe. So it references the probably version of Excel that was used, or the Excel binary that was used to author this in the first place. Talks about what is used for it, and then actually goes in and references, say, which workbook and which sheet that it uses, and then also has a reference to this module, which is module 1, which I remember seeing as one of the streams that was listed in the directory right here. So it refers to all three of these things. And then when I went down here, it's got a whole bunch of lists of these different like function names and everything here. But there wasn't a huge amount of, there's not a huge amount of data here, so what I ended up doing was I went back and I remembered that I saw the module there, module 1, and so I went and looked into that. And then when I look into the module, there's a large, and this is a lot of times what you'll end up doing for a lot of the analysis is you will be paging through kind of large sequences of hexadecimal code like this, or hex dumped code, looking for something that makes a little bit of sense. And then eventually I get down to something that looks almost like some code referencing something. So for instance, this looks like it almost does an assignment, calls a function, maybe has an array. It's all broken up, and one of the things I will say is that this data is also compressed. So in addition to it being broken up possibly within the file, it also has the ability to compress the data. So what you're seeing here is really the tree that builds up the probably run length encoding compression algorithm that's used to compress this data. So as you can see, I've been walking through this, and this would be a real painful thing for me to manually reconstruct. Although all the documentation for reconstructing it does exist out there and was used for building these tools. What I will do, though, is I will load up. There's another tool that has also been found to be very useful, and it's called OLE VBA. And it allows you to, let me do this so you can see it all. So if you run it, you give it that file, it actually has a large number of options here on how you want it to behave and everything like that. So one of these is to display the source code if you want, also to do some analysis. So this tool has the ability both to go in, reconstruct the code streams, and then extract and decompress the data within those code streams. Once it has source code, then it actually has the ability to analyze the source code based upon, and then measure it based upon a number of characteristics that it thinks might be suspicious. So if I run this, OLE VBA, and I'll just give it the -A option, I'll run it against the payment. What it does is it goes through and it shows me that there's a macro in this workbook. So there's a thisworkbook.cls, which is VBA class file, sheet1.cls. So if you remember, all these things ended up also showing up in here, right? There's a this workbook. Whoops. There's a this workbook. There's a sheet one, and there's a module one, right? And we were kind of walking through that, trying to gradually put the pieces together. This tool shortcutted a lot of that work for us. And there's a module 1.bas. So if you remember, we were looking through it. It looked like there was possibly some executable code in there, but you couldn't really put it together because it was compressed. So this actually managed to reconstruct all those things and even give them the files, or the file names. And then what it did was it analyzed the source code in there, and it told us that it does this particular behavior, which is suspicious. Basically, this one says that there is a macro that's assigned to automatically run when you open the file. So that's an event that Microsoft Word can automatically run a macro against when you open the file. Just like in JavaScript for your web browser, you can have an onload event and stuff like that. There's a suspicious it said it looks like it did some analysis and ran the shell function, which may run executable file or system commands. So this is where it is trying to run something that's on the hard drive of the system, an arbitrary program, which may be an odd thing for it to do. And then finally, it noticed that there were some strings in the macro that were hex encoded, which may be a way to obfuscate data. So if you remember when we were looking at the PDF JavaScript code, we also saw that where there was long strings of hexadecimal code where they were trying to hide some binary data or maybe some other ASCII data within there. They're trying to do the same technique here. So basically using a different carrier, but a lot of the same methodology here, which is embed stuff in a macro and then allow the macro engine to go and execute it and try and run arbitrary code within your environment. So then, what I can do is I'll just do this. I should be able to do this. And so this is, I just output and let me set the background color to something that makes it readable. So what I ended up doing was instead of running the analysis, I now have it dumping the code out. And we can look at the source code that was being used to, or I should say that's being run when you open the file to try and look at it. And sure enough, what it looks like is there is a bunch of variables that are filled with these arbitrary arrays of data here, which I don't exactly know what it's doing with this yet, but that does end up looking rather interesting. And then it says if active document.grammatical errors.count is greater than or equal to 0, then run this code. Which means that for whatever reason, it may not always run this program. Maybe it'll only run it if the grammar checker is turned on or something like that. Or maybe the adversary set it up so that this will help them not run the program within their environment, or at the very least, this just ends up being something that will that'll be a check that causes it to not be recognized when it executes. And then what it ends up doing is it creates an array out of what look to be sub-elements of each one of these things. So if I go and look up NGA, for instance, up here, and I go 0, 1, 2, 3, 4, we'll see the .ex is there, right? And then if I look up HO, so if I go HO, I'll do this, look at the beginning, HO, then we're looking at 3, right? So 0, 1, 2, 3. So E space slash. So .exe space slash. So then if we go up to U, right? Let's see what U was. Yeah, there we go. This one ends up CMD. So my guess is 0, 1, 2, 3, 4, 5, 6, right? 6. So CMD .ex E space slash. So it's putting together a command that it wants to execute, but it's assembling it a little bit at a time. And that way, if you have something where you're trying to analyze this code to try and see what's going on, even if you get to the source code part, you can't understand exactly what's going on until you stitch all these strings back together. And that's where, like, you know, your kind of hands-on analysis comes into play. But these macros end up being very powerful. A lot of times, I will say that the attack vector does rely upon the end user typically being prompted with a box that might give them a warning or a notice at the top of their Office document that says, warning, this document has some macros. Click this button to enable the macros. But a lot of people, or they're hedging on the fact that among their target set, at least one person is going to click yes to that box or is going to click OK. So
this in the end is concatenating?
Yep. Yeah, in the end it's concatenating it, and it's also hiding a lot of these in arbitrary array locations. So you'd have to look through this. I will say that because this is Visual Basic, I could bring this into another Visual Basic interpreter, and I could have something run through these arrays and extract the, the sub-elements that are strings, and then most likely I could just go through the ordering that they're referenced down here to try and concatenate them myself. But that's that's like a really good example of a post-process type analysis. Find like construction that's built like this, and then figure out a way to identify it and differentiate it from all the other Visual Basic code that you're looking at, and then write a tool that once this layout or this scheme is detected, will reassemble this for you automatically, so that then you have a library of scripts or a library of tools you can feed all of your document or Visual Basic samples to, and then they'll automatically figure out which one they should be routed to, and then what you get in the outcome is is the reconstructed data that allow you to get on to the next scheme, which is what file is this trying to run, right? Because that's what you want to know, because then that's the behavior you want to look for on all the other systems in your environment where someone might have clicked on or opened another document.